At this point, we've played with a number of existing classifiers, right? We've played with ImageNet. We found a handful of dogs versus cats models. We even tried open that sort of XClip version, which allows you to put in open labels. If you found that still didn't work for you for whatever reason, there is another option, which is training your own classifier. So this video is going to go through two different processes of training your own classifier. Honestly, it's way, way easier than it used to be. We're going to do this in under an hour and actually have two models for ourselves, multiple models to be honest. 5 years ago, this would have taken, I don't know, months, and it would have been kind of expensive. It wouldn't take months, it would have taken a week. And it would have been very annoying and it wouldn't have even been that accurate. Like, classifiers at this point are almost a solved problem within the machine learning community. So we're going to look at how to do that today. So first thing you're going to do is you're going to need to create an account on huggingface.co. So the website is here. You'll just go in and sign up. You don't need to pay them for anything. It's a free account, but you will go in and set up an account there. You have to go through some of their authorization and I think they do email verification, that sort of thing. It's a little annoying, but that's what we need to do. So go do that before we set up anything else. All right, I'm going to assume that you've done that and you are back here ready to make a data set. So the next thing is we need to make a data set. Making a data set could be a very lengthy process. If you want to do something like as simple as fan cam kind of stuff or fan edits, then this might be quite easy. So I got the idea to do an X-Files Mulder versus Scully fan cam. So I'm going to make a classifier that sorts out Fox Mulder images from Dana Scully images, and I need to make a data set for this. So the easiest way to make a data set in a classifier is to create a master folder. Just name your master folder whatever category you think you want to label it as. So in my case, it's Mulder versus Scully. I could turn this into a whole X-Files fan cam. Maybe I just like the Smoking Man or other characters. And I could just label this as X-Files, and then I could have multiple folders in here. So within here, then you need all of the folders with your labels. So it could be Mulder, Scully, Smoking Man, whoever else. I clearly don't watch the show that much to know all the other characters. But in my case, I just want Mulder and Scully. And these names should be, there shouldn't be any spaces in the name. So if it's Fox Mulder, it should be Fox-Mulder. Try to keep the labels as simple as possible, but clear, obviously, for you. Next, we need to make a folder for each one of these and put images in that folder. Now, the number of images is kind of up to you. I would say at minimum, you want 20 images per folder. So I need 20 images of Mulder, 20 images of Scully. And honestly, all I did is I went on to Google Google search and I just Googled Fox Mulder X-Files, and I just honestly either downloaded images or in a lot of cases I just took screenshots. You can see these are just screenshots. So there were likely images that were quite large where it was both Fox, Mulder, and Scully, and all I did was, do a little screenshot of Mulder and downloaded them. Now, size doesn't matter, ratio doesn't matter, because the model's going to handle all of that. Size kind of matters. I wouldn't have them be 40 by 40. I would have them be a decent size. So 256 should be kind of the minimum size. Although you'll see here, this is 144 by 144. Actually, sorry, that's resolution. So there might be some smaller images in here, and in that case, it'll just kind of res them up. But ideally, they should be around 200 pixels by 200 pixels minimum. So I've got a bunch here for Mulder. I've got a bunch here for Scully. Now, realistically, 20 per folder is not ideal. I would probably shoot for 50 to 100 images per folder. But I did this very quickly, and the model still works quite well. So at the end of the day, it doesn't really matter that much. Now, one thing to remember is that with these labels, when I run this model, any image I pass it will be scored either Mulder or Scully. So when I pass it scenes from the X-Files that do not contain any of these characters, it's still going to label it as them. So in an ideal world, if we know we're going to have a lot of data that's outside of these two sources, I might want to go a little bit further and include other characters. That's just going to better sort your data. What we'll actually kind of do is we'll include some confidence scores when we run through these, so that we'll basically say only give me Mulder and Scully if they are higher than a 0.7 confidence score or something. So this is a down and dirty, very fast data set, but it works relatively well. If you want to spend a couple more hours actually filling out, maybe all the main cast of X-Files, that would work too. One other thing I should mention when we talk about the dataset images. So ideally, you get dataset images that are sort of like from different angles. So like try to find some profile views. So there's a profile view, looking up, looking down, maybe from the back of their head even. One thing you could do is if you're working off of a movie dataset, you could actually go through your data in your movie and actually like screenshot, scenes directly from there. Now that's kind of cheating, and it might lead to a thing called overfitting, which would probably still work fine for this model. You could even look up the actual actor or actress and just take screenshots of them. That works pretty well too. What we're going to find is that with this particular model, it is actually going to kind of learn gender roles, which I kind of hate, but that's kind of what's happening here. This model will end up being like a traditional cisgender male versus female classifier, which not ideal, but it is what it is, and it works fairly well in our use case. So just beware of that. But once you've got your data set done, like you're basically 80% of the way there. Like making your data set is actually the hardest part of this. So, if you are, you could also do locations. So maybe you want outdoor scenes, indoor scenes. Maybe you have like specific locations you're looking for. So, I want, a beach scene versus a forest scene versus a city scene. You could set up labels for all of that. Like the reality is with a classifier, like unless you're getting really, really down in the weeds and getting really nitpicky, a classifier is generally going to learn like a decent bit about your images in a very short period of time, and you'll be able to create a classifier that does one particular thing relatively well. So yeah, this is basically all you need to do for your data set. So at this point now we can go ahead and get started with Hugging Face. So I'm going to go back to my Hugging Face model here, and I'm going to go I believe to this is interesting, where do I go for this? I'm going to type in Hugging Face AutoTrain. So I'm going to show you two different examples here. So one is I'm going to show you a completely GUI version that uses Hugging Face, which is called AutoTrain. So it's at huggingface.co/AutoTrain. I'm then going to also show you a version that uses Colab. So AutoTrain will cost you, I don't know, a couple bucks per model that you make. I want to say in my example, I have this thing called Hugging Face Pro, which costs like $10 a month. So I think I get a discounted price on my models. But I would guess that if you don't have that, it's probably like $5 a model, which is relatively cheap, and we'll find this process very, very fast. So if you're like, I don't know which one to choose between AutoTrain and Colab, and you're okay with spending $5, use AutoTrain. It's way, way faster, and it's super easy. The Colab version is great. It's fine. But it's, some running lots of cells and then waiting a little bit and then having to do some manual work a little bit on your own end. So my recommendation for anyone that's just like not sure what to do, use AutoTrain. Again, you do have to pay a couple bucks, but it's worth it. So we're going to start here, and then I will show you the version that is in Colab. And in YouTube, I'll make sure I mark the moments in the video where we skip. So if you want to skip ahead and just do the Colab version because it's free, go for it. And then we'll also do Inference after that using the same model from both of these examples. So let's go ahead and use AutoTrain here. So we'll go ahead and create a new project. And I'm going to assume you're logged in to your Hugging Face model as well. So we're going to create a new project. And I'm just going to call this project Mulder Scully Demo. I've already run this a couple times, but this is the best way to get started. So label your project whatever your data set is labeled. That's probably the easiest way to do it. Next is, this is a vision task, and we are doing image classification. There are other tasks here, which we won't get into in this class, but in this one, we're going to do image classification. And I recommend for model choice, leave it at automatic. It's probably going to use a model called Swin. Totally fine. It works great. Whatever. So we're just going to create our project now. And now you'll see that we are on the Data tab, and we're ready to upload our data. So what we can do now is we can just go over to our Finder where we created all of our folders, grab the root path, right, the base name with all of our labels, and I'm just going to switch back and upload this here. And you'll see that when we upload it, it loads in our project. It gives us our master folder, and it gives us each of our labels. And from here, we also see how many images are in each folder. So I see inside my Scully folder, there are 20 images, and inside of Mulder, there are 20 images. And it's going to ask me, how do I want to split this? Splitting is basically a way that scientifically, we don't want to show all of our images to our model because it's going to learn to cheat. So we hold out a couple images in order to test on. So this is splitting things out into that testing scenario. I would set it to auto. Doesn't matter. This is going to be good enough. And then we'll hit add to project. And this is just going to upload all of our files to Huggingface. And now we've got everything here. So at this point, we can go ahead and hit go to trainings. And this is going to figure out what the best training options are for us. Again, I think 9 times out of 10, it's going to choose Swin over other models. But this will tell you sort of like, hey, here's what we think will work for you. And this just takes a little bit to sort of format your data and then figure out what model it should be using. So I should mention, maybe we mentioned this a little bit in the lecture, but what we're going to do is actually going to what's called fine-tuning. So we're going to fine-tune on top of a pre-trained model. So these big labs, Google, Windows, other companies spend millions of dollars training models that we can then train on top of for $10. And that's sort of the key here, is that someone's gone through a lot of the work to train the model fully, and then what we do is we just say like, hey, using what you already know, can you add a couple of these data points into this model? Honestly, can't believe this is taking this long. I remember this being much, much faster. Here we go. Okay, cool. All right, here we go. So now here's the other thing that we need to figure out is how much do we want to spend and how many models do we want to make? So the reason you might want to make multiple models is remember that there's a little bit of randomness in training. So as you train a model, some models do better than others just purely based on random chance. So the chance here is like if I train 5 models, I have a higher likelihood of one of them performing really well. If I train one model, I'm kind of taking one shot and just like hoping that it works well. You'll see the price here is, so I think because I'm on Hugging Face Pro, I think my price might be a little bit lower than yours. I don't know what your price is. I hope it's not over $20. If it's over $20, let me know. If it's that high, I would probably choose 3 models and your price will be cheaper. I think 5 models is good. That's way it's just going to generate a bunch of models for you and it will automatically tell you which one is the best. And that way you'll be able to make sure you get the best model possible. It's going to cost me $12. Honestly, that's totally fine and quite worth it, to be honest, for what we're doing here. So I'm going to choose 5. You can feel free to choose whatever you want. If you want to go ham and choose 10 and spend $27, you're more than welcome to. But I think 3 or 5 is probably fine. And honestly, if you don't want to spend very much money at all, 1 will probably also be okay. So let's go ahead and hit Start Models Training. Yes, I'm okay with being billed $12. And this is going to start running. Now, this does take a little bit of time. If all of us in this class run this all at once, we'll likely be in a queue. But because we're all doing this asynchronously, we'll probably be fine. These models are queued, and then they run, and they honestly run for about a minute, 2 minutes. It's super, super short. So see, all of these are starting up. This one's now moving into processing, and in like a couple minutes, we'll be done with this. And this is what's really cool about this tool. This is actually the first time I used this in prep for this class, and I was really surprised at how good it is. And honestly, like, I don't think I would use anything else. I'm okay with spending $3 or $4 per model. If you are not, totally fine. The Colab version works just as well. One note is the Colab version only makes 1 model. So actually what I recommend we do in that one, and we'll look at that in a minute, is we'll actually change the epochs to be a little bit higher. That hopefully grants us like the best opportunity. So these are still training. You'll see all of them are now training. Some out of the queue, and they're all working on training. And you'll see here at the top, we've got an accuracy score. And the accuracy score basically tells us like how well it was doing based on that validation set. So this one finished and it has a 75% accuracy. And these other ones should probably be finishing soon as well and should hit about that same accuracy score. There's another one that's done. This one had an impressively low score for accuracy, so we probably won't be using that one. That makes me think something almost actually went wrong with that training set. It's very hard to hit that low of an accuracy score. That's less than 50%. That's less than a coin flip. That's really bad. Now, if you ran just one model and you got that low of a score, like I would definitely run it again. Your accuracy score, especially with a model of this size, should be at least 75%. And when I ran this in prep for this session last couple days ago, I actually did get a 100% accuracy score for one of them. And again, remember that like with our model, it's actually like not really 100% accurate. Like that's not always going to be true. It's a sort of based on the training data set we've got here. So in this case, we're sort of seeing here that we've got all of our models finished. And you'll see it doesn't really rank any one of them as the best because we have 4 of them that all have 75% accuracy. So I'm just going to refresh this page here and see if it gives me a score for what it recommends. Okay, it doesn't look like it does. Let's look at metrics. So based on this, the key thing to look for is that the loss score is as low as possible and the accuracy score is as high as possible. So I would actually probably pick this one that's called Aware Alpaca. All of these models are now immediately saved into your Huggingface account. So if I click on this, it's actually going to take me right to that model. And what we're going to do in the next step after if you skip the Colab training, we're going to take this model and bring it into our Colab notebook and actually use this to then do the inference and operate on all of our video. So this will be pretty easy, and all we'll want to do is we'll hit copy right here. Now I do want to show you, let's go back to my models. I've got a bunch of models in here, but let me show you, let's go my account to profile. You'll see in here that now inside of models are all of your models, and I think this one is the one I want. Nope, that's not. One of these in here actually does have 100% accuracy. Bug, quiet, baby. Come on, chill out. Maybe it's this one. Yeah, it's this one. So you'll see that my accuracy here and my loss here were much, much better. And this is kind of why you want to run a bunch of different models. With AutoTrain, you can't really set how many epochs it runs for and other things. So in that case, you just kind of want to work with the best model possible. And again, it's always loss being as low as possible and accuracy being as high as possible. So in this case, this model was better than the other one based on, some of the randomness. So I might use this model in my example. Now, if you got a model that was 75% accuracy and had a loss score of 0.5 or so, it's probably fine to still run it. Don't spend more money than you need to. Maybe run the Colab version and see if you get better results, but overall, you're probably fine using this. So that was literally it for AutoTrain. That's why it's cool. That's why I really like it and why I would recommend it to most folks, because it's really easy to use. That took no time in order to generate 5 models, and we got to pick our best one. Now we're going to jump over to the Colab version. If you found this is good enough for you, like skip the Colab version. You can always come back to it and try it. But if you are interested in to see how the Colab version works, we'll go to that video now. If you don't want to spend money through Huggingface, that's fine. I completely get it. It is slightly expensive. There's another method which we'll go through now, which just uses Colab. So obviously if you've already spent for Colab and already have Colab credits, this is free, essentially. You do still need to make your Hugging Face account, because we will be uploading this to Hugging Face in the same way that our other models appeared there. You will also need to still do the dataset preparation steps, and they're the exact same. So you'll make 2 folders. I guess assuming you have 2 labels, you'll make however many folders you need for labels, and you'll upload images to there. And again, let's say minimum is like 20 per folder, anywhere up to, hundreds of images if you have them. So you'll do that, and then what we'll do is we'll actually zip up that folder. So that's the one difference, is you'll need to make a zip of that folder. So if you're on Mac, you can just quickly go here and go compress and then your folder name, and that'll make a zip, and then we'll upload that to Colab in just a second. So let's go ahead and get started with this Colab notebook. So this is actually a notebook that Hugging Face provides, and all I did was update a couple little things. So it's very wordy compared to my other notebooks, and there might be stuff in here you don't understand. Just know that I'm going to walk us through the process, and it's not that hard. I know it's easy for me to say that, but it's actually just mostly running all the cells and making very few edits. And where you make edits, I've already called that out, and I'll call it out here as well. The GPU for this, I think you do need a GPU in order to do training. I think a V100 is fine. You can probably get away with a T4. I don't think there's that large of a VRAM requirement. But I think a V100 is nice. It's fast. It'll happen really quickly. And this is actually a pretty quick process. A little bit slower than the Hugging Face AutoTrain, but it is still pretty quick. So let's go ahead and connect to our notebook. We'll just hit over here and click to connect. And then we'll just start scrolling through here. So the first thing we're going to run is we're going to, we haven't talked about this too much, but we're going to use a pre-trained network and fine-tune on top of that, which means someone with lots of money has already trained one of these models to work really, really well, and all we're going to do is take it and add in our existing data and say hey, also include these labels. So that's what we're going to do here. We're going to use the Swin Tiny Patch for Windows 7 224. I don't know this particular model, but it's what they recommend here, and I've found it works pretty well. So we'll go ahead and run that cell. Next, we need to install some libraries. So we'll run these 2. One thing I should note here is this was a required update for this notebook using the Swin library. I don't know why it's this particular one. I hope, at least for the next couple weeks, this will still work. But if you're coming at this a couple months later and you're finding issues, this might be why. We'll figure it out. Just drop a note in my YouTube video if that's an issue. Next, we still need to connect to Hugging Face. So as always, log into your Hugging Face account. And what we're going to do here is we are going to go to our account, and then we're going to go to Settings, and then we're going to go to Access Tokens. And you probably don't have any access tokens, so we're just going to create a new one. And we'll call this Classifier. And we need to give it a role of write as well. So you're going to go ahead and hit Generate Token. And then all you have to do is click the copy button here. So copy it, come back over to your notebook, and then run this cell. And it's going to say, give us your token. So you're going to paste in that token and hit Login. All this does is it basically connects what we're going to do here in this notebook to your Hugging Face account, so that then you can upload your model directly to Hugging Face. We'll run this cell, which just allows us to upload large files. We can skip this cell, actually. We don't need this. I'm just going to delete this. So it isn't there. Okay, cool. So now we're going to fine-tune our image, our model, on our task. So the key here is we need to get our data into our Colab notebook. We could use Drive. I think it's actually just easier to just upload a zip file. So I'm just going to upload our zip here. If your zip is massively large, then you might want to do it through Drive, but it's the same process if it is in Drive or not. In fact, what I'll do here is while that uploads, I'll add a cell here for connecting to Drive. So if you do want to connect to the Drive, you can just run that. almost there. Unfortunately, Colab doesn't really let you upload folders directly, even though it seems like it supports it, it doesn't. So what we're going to do is we're going to upload our zip file, and then we're going to unzip our file to get our folder path. So what we're going to do here is we're just going to click on our zip file, right-click on it, copy path, paste that path in, and then run this first cell. And all that's going to do is unzip our folder here. So if we refresh, we'll see we've got this Mac OS folder, which we don't need. We can just delete that, and then the Mulder versus Scully folder. Actually, I'm not even going to delete this because it's not really worth it. So let's just copy this path for this folder, and we're going to paste that in here, and then we're going to run this cell. And you'll see now it's going to basically pull in all of our images, and it's going to tell us how many images are here. So there are 40 images, and that's because I've got 20 for each folder. So again, that's probably the minimum for this. This model still works fairly well, but ideally, probably have a couple more images per data set. Okay, we need to load in our metrics. Again, this stuff probably doesn't really matter to you as much, but just know that when we train our model, we want to make sure that the metrics or the stats we're doing as we do training are the right ones we want for this model. And the idea is we want our model to be as accurate as possible. So we're going to load in some metrics that allow us to track accuracy. I'm going to run this just to quickly tell you what's going on here. So our data set is loaded as this sort of a dict, which is a Python convention. And you'll see in here we've got a training data set. So remember, this is our training data set we're going to train the model on. And you'll see here that there are images and there are labels, and there are a total of 40 of them. And if we load in one of these as an example, we'll find out that it's a PNG. It's actually an RGBA file, and our size is this, and our label is 0. Now you might be like, well, isn't our label Mully or Sculder? Mulder or Scully? And it is, but we always convert labels to IDs because it makes numbers easier to work with within these models. If you want to check exactly what the features are of this, you can run this, and you'll see that there is an image, and there are class labels, and you'll see our classes are Mulder and Scully, and label of 0 means it is a Mulder image because it is the 0th index of our labels. If it had an index of 1, it would be a Scully image. This cell will allow us to run this and actually see it, see what the image is, and there it is. There's our big picture of Mulder. And if we run this, this will tell us what the label is, and like we said, it's 0. In order to get out the labels, we actually need to run this to see what our labels are, Mulder and Scully. And then this creates a little index that we can then reference. So this turns our labels into IDs and our IDs into labels. And we run this and we ask for what is the first ID of ID to label, and that would be Scully. Remember, in Python, in most programming languages, 0 index is actually the first. So if we were to run this with 0, we would get Mulder. Again, just details that probably don't really matter for the training process, because really all we want out of this is a training model. But if you are interested in the behind the scenes of this, this is kind of what's going on. Next, we never actually read in our images as exactly the images we see when we upload our data set. We do what's called augmentation. And augmentation just means sometimes the images are cropped or rotated, or the colors are changed in them. And the way to think about that is that, as humans, we can recognize our cats or our dogs or humans as them still, even if they're behind half a door, so we only see half their face, or if they're laying down and they're at a weird angle. That's kind of what this model is training. It learns even representations of the person's image that aren't even the images we upload, and that makes these models actually work a little bit better. So we're basically just loading in this what's called image processor, which allows us to do some of those changes. Next here, we need to actually load in a bunch of other functions. And again, this is all about those transforms and those augmentations. Basically, what you want to do is when you train the model, you want to create lots of different transformations or augmentations. But when you actually read in the data for doing inference or for actually classifying, you don't really want to change it that much, because changing it more might actually affect what the class would be, and there's other ways that can happen there. So here we're defining just how we would actually augment things during either training or evaluation or during inference. This is getting a little bit in the weeds, but we don't actually train on the full data set. That's a bad scientific practice. What you usually do is you hold out certain images so that you train on a certain set of data, and then you evaluate on a separate set of data, and therefore you get a better scientifically accuracy number because basically you're not like cheating on the test, essentially, is basically what it is. So in this cell, we're actually going to hold out part of our data set, and this is why you actually want a decent number of images. With a data set of 40, we're actually only going to hold out 4 images in total, and that's not great. So like this is where you would want more images. So maybe 40 of each label is actually probably better, because then when you hold that out, you get 4 images per data set. It just makes everything a little bit better, a little bit easier to guess accuracy. I'm going to run this anyway with the 20 images. It does still work fairly well, as we'll see when we actually process this, but that's all this cell is doing, is it's going to split out some of our data so we can evaluate on that. And then we'll run this, which then applies those augmentations to the data. And if we want to look at what that data actually looks like, it looks like this. There's an image file, there's a label, and then there are what are called tensors. This just basically converts our pixel data into these values. And this is actually the values that the machine learning model operates on. Remember, there's no such thing as a pixel, or sorry, there's no such thing as a picture to these models. It's all a bunch of pixel values. Okay, now we're about set to train. So here's where we're going to actually load in our existing model that we're going to fine tune off of. So this is where we're going to load in the pre-trained model, and then we're going to add to it. And if you want to read a little bit more, there's a little bit more in this Huggingface notebook about what that means. You're going to see this thing that kind of looks like an error message, but it's not really. It's basically just saying, like, make sure you train on this model, because we're dropping certain elements of it. So you can't use this as a classifier by itself. We have to train on top of it. The next thing, this is probably the 2 most important things you want to do for this particular notebook, in addition to uploading your data set, is we want to set a project name. So this is where I would name something so you know what it is. So it would probably be like, what are you classifying? And then for me, because I did the AutoTrain as well, I want to make sure I label it as Colab. Now I actually ran this before as well, so I want to call this Colab 2, just so I've got different models there. Number of epochs. So this is getting a little bit in the weeds, but basically we train on multiple iterations of our data set. So we run it over and over and over again, and it learns over time. Number of epochs is how many times it should run. My guess is like between 10 and 20 is good. You could crank it up. The more you crank it up, the more you risk what's called overfitting. I would say if you have a lot more images, then you need to lower this. So if you're only at 20 images per label, 20 is probably good here. If you have, say, 100 images per data set or per label, then maybe 10 or even 5 is enough. Generally what happens is the number of epochs and the amount of data you have determines how long training is going to take. So I've only got 40 images and I've got 20 epochs and I'm using a V100. This training is going to take like 5 to 10 minutes. It's going to be about as fast as that AutoTrain was. So just know that like it's only 5 minutes. This is not that crazy of a process. If you've taken my StyleGAN classes, you know training there takes forever. This is way less. So I think a good default would be 20 if you only have 20 to 30 images per label. If you're at the 100 mark, maybe like turn this down a little bit. So let's go ahead and run this cell. And this is just going to save all of our training arguments. We're going to write a function here that actually does our computation of our accuracy metrics. And then there's more stuff here that we don't need to worry about, but we'll run this cell as well. And then we want to actually implement our trainer. So this just passes everything we've just created here to our training model. And you'll see it's cloning in a bunch of things. All that we need to know is it's basically setting this up. Now this cell is actually where we run our training. So you'll see this thing here that says trainer.train. This is actually going to run the training. Now again, it's only going to take like 5-ish minutes in this example. But this will actually be how we run our metric. So let's go ahead and run this now because we are set up. And you'll see here now it's just running through our epochs. So it's running through, this number here is like all of the images in our data set. And then it's just creating epochs. And you'll see along the right-hand side here, you've got this accuracy metric. And this accuracy metric and the way that this data set is built is a little deceiving because there's only 4 images in our accuracy model that it's testing against. It's like literally only 1.0, 0.75, 0.5, or 0.25. So if this goes up and down a little bit, it's totally fine. I wouldn't worry about that. The other thing we want to notice is that our validation loss is going down. Ideally, we want our validation loss as low as possible and our accuracy as high as possible. So this is just going to run for another couple minutes. You'll see this is very fast. Just like with AutoTrain, it's a very fast process. But all that setup we did beforehand is probably longer than it would take to run AutoTrain. So this is kind of where I say, like, it's kind of worth the money, especially if you feel uncomfortable running Colab. Then that AutoTrain is like very, very cheap and like worth its value. So we are now done. We'll see here our metrics are, our training or validation loss is very low or lowish compared to where it started. Our accuracy is at 1.0, which is great. That means it's able to guess all of the images that it was given, even though that was only 4, right? So it's able to take 2 of the Mulder and 2 of the Scully and accurately guess between those. You'll see it basically at some point it became like really hard for it to not differentiate between those. And then we've got some other scoring here as well. Now, at this point, we're pretty much done. This thing is going to just double check our metrics to make sure that the scoring here is accurate and that we're pulling in the best version of our model. Because there is a chance that, as you go through this, that at some point maybe this has the lowest validation loss and this has the highest accuracy, but it keeps training to try and find better, but it never finds something better. We want to make sure we're loading in the best quote-unquote model based on our metrics. So that's all this cell does, is it just double checks us. And it'll say, the best epoch was epoch 20, and here are some of the scores from it, and that's it. Last thing we want to do is we actually want to push our model up to Huggingface. Now, one thing I should mention is that by default, using this setup, your model is public. So when we push this up to Huggingface, you will see that your model is publicly available. You can quickly change that if you want to, but I just want you to be aware that, like, for a couple seconds or a couple minutes, your model will be public. No one's going to steal it. No one's even going to find it, to be honest. But if you are super worried about privacy, Nick, no, that's a slight issue here. This is now pushing our model up to Huggingface, and now it gives you our address right here. So if you wanted to, you could just copy and paste this directly into a new window, and there is our model. If you want to make your model private, you can go to Settings, and you can set this to make private right here at the top. I don't care. I'm going to leave mine public because who really cares? At this point, you are basically done. We will pick up in our next video a new notebook to do inference on, and it'll be connected to Drive. It'll basically act just like all the other notebooks we've been using to classify our video data sets. One last thing is make sure you remember to turn off your machine by hitting disconnect and delete runtime. That just makes sure that our machine is off. It's a V100. It's burning some credits, but overall this process took, maybe 20 minutes. So definitely longer than that AutoTrain feature, but if you're already paying for Colab credits, it's free. Okay, and with that, we're going to switch over to another notebook to actually do our inference and run all this and save our data to our JSON. Okay, now that we've trained our classifier, either in AutoTrain or in Colab, we're now ready to bring it in and start using it, right? So over here, I've got both of these models that I made. So this first one, you'll see it starts with AutoTrain, which means it was the AutoTrain model. It has an accuracy of 1.0 and a loss of 0.302. And then here is the Colab model that I trained. It also has an accuracy of 1.0 and has a loss of 0.3652. Which one should I use? They're probably going to be about the same. I'm going to choose the one that just has a little bit of lower loss score, just to see how good that one works. So you can pick from your models as well if you did both. I would guess that maybe I'm actually kind of surprised the AutoTrain one is better than the Colab one. I would have guessed the Colab one would be better, but so it goes. Maybe your Colab model was better than the AutoTrain model. I don't know. Okay, so we're going to go over to this notebook. This notebook will look like many of the other notebooks we're using in this class because at this point, they're all kind of the same. They go through the same process. The only difference here will be we'll load in our pre-trained model from Huggingface. Okay, so let's go ahead and connect. Again, I would probably recommend a GPU for this one, but a T4 is totally fine. Go ahead and hit save, and then we'll connect. And then, as always, our first thing to do is we're going to connect to Google Drive. And then we're going to install the Transformers library. We'll refresh our folder, and then we'll go to Drive, My Drive, Algo Film. And now, I'm going to assume that everyone has run this cell at least once here, but if you haven't, just remember this allows you to convert your clips to frames. And remember, we don't really want every single frame because that's going to be a lot of data and it's going to be slow to process. So I'd say a frame rate of like 1, 2, maybe 0.5 is probably fine. Now remember, we want this for the data matching our trained model. So in my case, I was looking for Mulder and Scully, so I need to make sure I'm running this on the X files. Now I guess I could go and find like other films that those actors and actresses were in, and like try to pull them out of it too if I wanted to. It probably would work, to be honest. But in this case, I just want to go through X files. So I've already run this, and you'll see I've got a frame folder here called X files, the first episode, and it's 1 frame per second. And inside of all there is all of my images. So I'm going to skip this step. You can run it if you want to. Just remember this takes a little bit of time. So it does take, a handful of, on a 90-minute film, it takes about an hour and a half. On a short trailer or something else, it's probably pretty short. We'll skip that stuff as well. Okay, so now we're ready to actually import our model and run it and see how well it works. So the key here is this model HF needs to take in this name here. So you don't pass in the full URL because that will, I think that might still work, but in this case, what we actually want to do is we want to copy using this copy tool right here. Actually, this is not the right model. I'm going to close that. I want this model. So hit the little copy button right here, and that's going to copy in the DVS or whatever your username is, and then your model name. So we're going to paste that in here, and then we're going to run this cell. And this should only take a minute or two. The other thing I should say is if you make your model public and you want to share it with the class, you're more than welcome to. Maybe you made a really cool, somewhat useful, generic model that you could then reuse. So for example, we could have made that shot type model, we could have made that as a single image model and seen how that worked compared to that video model that I made. So everyone's up for a task, you try that and see how it goes. Okay, our model is loaded. Let's run this cell. This is just going to tell us what the IDs and labels are. I obviously am the 0 index for the ID is Mulder, and ID of 1 is Scully for me. You should see your labels here. You should not see my labels. So hopefully you see that. Next, let's go ahead and load in a single image and then see how it works. So I'm going to go in here and hopefully find an image that is either Mulder or Scully very easily. There we go. There's one of Scully. So let's go ahead. I'm gonna add a little cell up here for us. So image path equals, And then we'll okay, so I'm going to copy in this path. And let me just run that here. Cool. So now if I run this cell, I should get out a prediction of Scully. There we go, Scully. So that is everything that we want, right? Like this is basically our model. We now have a custom model that can accurately assess any data we provide it. Now remember, this does work on images. It does not work on videos. So it is purely based on the image of a frame. But as we've seen before, that's actually, we can work off that, right? So in this case, what we're going to do is we are going to grab all of the images in our folder, and we're going to classify each one of them, and then we're going to pull out whatever we think is the most common classification for that clip. So let's go ahead and run this. This is going to run in our functions that just allow us to do that. And then let's point this to a folder. So we'll grab the master folder here. We'll paste that in, and we'll hit run. And it didn't print our label, so let's say print label. There we go. So with a 58% accuracy, it believes this is a folder, a clip with Scully in it. Now again, remember, this can only be Scully or Mulder. If I feed it a clip that contains both of them talking to each other in a scene, it will give me one or the other, but it might be a low accuracy score or a low confidence score in that regard. So we're going to have to kind of work off this. And also I would say, like, this looks, it should be more confident than this about this image, about these images. That should be quite confidently Scully. This is one of the challenges, is you might say like, wow, it should be more confident, but the model actually isn't. Why is that? Well, we did train, I at least trained my model on a very low amount of images. Funny things happen where like maybe the images I uploaded of Mulder all have a window behind them. And what the model ends up learning is that Mulder lives in a office with windows and Scully is out in the field. This is a case where if you're finding that your confidence scores aren't really the way you want them to be, you might actually want to retrain the model with more data. So in this case, if I were to do this for real, like if this were like a production project where like, you know, my team was depending on me for this to be successful, I might even cheat a little bit and actually use this image, feed it back into my model, and have it update so that hopefully I get a better confidence score here. Because as we go through this, we're going to look and actually try to pull out videos that only have a high confidence score. And this video would not be included because it has a low confidence score. And this is kind of the challenge of these tools, is you might have to go back and forth a little bit with them to get them to work. Maybe I just want to actually just pull in anything with a higher confidence score than 0.5 and just deal with what I have and use EDL to edit the clips in Resolve or in Premiere or whatever. But anyway, this is working for us. Now we can go ahead and run this across all of our folders. So as before, actually there's two different versions here. So because it's kind of a custom classifier, we might not actually want this in all of our cases to be in our JSON data store, right? We might just want to run this on just this one video folder, in which case this clip or this cell will only operate and not save our stuff to data, to the JSON data file. Oh, interesting. The version that is saving it is not here. I will add that because we already have that from a previous class. So this version will and then below here, you'll find a version that does save to JSON. So I'll also throw in all of the other tools we already have that also allow you to combine videos based on those classes, and then also the EDL. So at the end of this notebook, you'll find all the tools that match what we've been previously doing across all of our other classifiers. I think I just never updated this file. So this is it. We've now got a custom classifier. We could go and retrain it if we wanted to get more data. We could try a different approach to the thing and see how that works. Sorry, my cat has been very, very mouthy for this whole video. So we've got a custom classifier that works, and that's what's really cool about this, is we're able to, in an hour, make a really good classifier that we can then leverage on future techniques. So I hope you found this fascinating and interesting and cool, and I hope you make a cool custom classifier for class. And if you do want to share it, again, more than welcome to post it in Slack. All right, I think we've got some other techniques we're going to look at next, so we'll jump to those now.